A batter hits a pop fly into a shallow center field. The ball is hit 1.1 meters above the ground at a speed of 29.5 meters per second in a direction 42.5 degrees above the horizontal. Okay. Then it says stuff about this center fielder. He says he's 116 meters from home plate. So from here all the way over to the center fielder, it's 116 meters. The ball was hit toward that person, and the center fielder is going to run to try and catch it where it comes down at the height it was hit. So that thing about the 1.1 meters above the ground is actually unnecessary. It's going to be hit from a height of 1.1 meters. It's going to come down to a height of 1.1 meters. So in the end, it's just like, hey, let's not call that 1.1 meters above the ground. Let's just call that 0. So that's what I'm going to do. Okay. I'm going to put the center fielder in later. Right now, let's just figure out where the ball comes down. Okay? That's all. Let's just find out where the ball comes down. So there is an equation for range, but I don't like using it. I'm going to go all the way from scratch, okay? It's more useful for us if we go from scratch. So, I need to know how long it's in the air first. Okay. So, I know that the ball starts at a position of, well, okay, how about it starts at a position of 1.1 meters and it ends at a position of 1.1 meters. Okay. That's easier than trying to figure that out. V naught y is going to be 29.5, 42.5 degrees. You know what, so I don't have to write all, well, okay, yeah. 29.5 times the sine of 42.5 degrees, which is a number that I don't want to use because I'd have to round and it's annoying, so just put it in. Okay. I don't know what V is when it comes down, although symmetrically speaking, it should be just the opposite of this, but we don't even need it, so we're just going to leave it out. Okay. Well, we could put it in, and then it would be... No, let's not use it. Okay. Too much. Last problem. I just want to get it done. So do you, right? Right. Okay. I need to know the time. Okay. The only equation that's going to work is this one. Put some zeros in. Well, okay, check this out. I put in the 1.1 here, equals 1.1 plus v naught y t plus 1/2 a t squared. See, I subtract 1.1 from both sides and I end up just getting 0 anyways. That's what I meant by, like, it doesn't really matter, you can just call it 0 anyways. That's what ends up happening. Okay, so what I have here is I've got a t in the both remaining terms, so I can pull a t out and I can factor it out, and that gives me one solution that t equals 0. That makes sense. That is the time at which it was on the ground at the beginning. But I want to know the rest of it. So when I factor a t out, that still equals 0. And I solve that for t, what I end up with is negative v naught y equals 1/2 a t. Multiply both sides by 2, divide by a, and I get this. Okay, which in this case is, oh, I don't have enough room to do that. Hang on. Okay, I end up with negative 2 times 29.5 sine 42.5 all over negative 9.8. Put that in the calculator. And I get 4.07 seconds. Store that in your calculator because we're about to use it again. Okay. Storing. Good. Now, with that amount of time, the distance it goes we're going to use this equation. That's an x. That's an x, I swear. Okay, keep in mind that in the x direction, acceleration is 0, and let's assume starting from 0, in which case x just becomes Vx naught, so that is V naught cosine angle times time. Okay, so that gives me 88.5 meters. Okay, so what I'm saying here is that this is 88.5 meters, but there we go. But the that center fielder guy was all the way over at 116 meters. Center fielder dude. Shoot, I'm like, okay, I'm gonna draw over some of my previous stuff. Sorry. He's way over here at 116 meters from the plate. Needs to catch this ball. No, it's way over there. So he's got to run over back this way. 116 minus 88.5 meters, which is, let's see, 116 minus 88.5 meters. That is 27.5 meters. Come on. So he's got to run 27.5 meters right when the ball was hit. It says, assuming that he starts running the instant the ball was hit. So what I've got here is that this guy has got to run from 0 to, basically he's got to run, hang on, better. He's got to run a total of a 27.5 meter displacement, and he's got to do it in the time it takes from the ball being hit to getting here, which we already calculated was 4.07 seconds. Okay, so his velocity, we could use average velocity, because let's just assume that it's either he runs the same like constant velocity the whole way, or he does an average velocity. But either way, it's going to be how far he runs divided by how long it takes him. So he runs this far in this amount of time. So his velocity has to be 6.77 meters per second. That's it's pretty good. It's pretty fast. Well, actually I don't really know. Faster than I can run anyway, since I can't run.